Hi, in this video, we will look at the chapter The Human Eye and the Beautiful World. Human eye is so amazing. It is the only reason why we are able to look at the beautiful colors. We are able to appreciate the amazing shades of the sky. We are able to look at the tiny colorful things and appreciate it. Okay, so the eyes are so important. Let us look at some more facts of the eye. The eye is composed of more than 2 million working parts. Just imagine 2 million parts are working together to help us see. Isn't that amazing? And most of our memories are comprised of what we see, correct? And a fingerprint that it is used for mobiles, and it is used for Aadhaar card, so many purposes. So this has 40 unique characteristics. There are 40 points on a fingerprint which will be unique between you, me, and anybody around you. But an iris, that is the colored part of the eye, it has a 256 unique parts. Okay, this is why iris scanning is becoming more popular these days. And the eyes are the second most complex organ after the brain. See, there are so many amazing organs in our body, like the heart, stomach, the whole digestive system, and hormonal system. All of them are insanely complex and very hard to understand. But the eye is more complex than all of that. It's just second to brain. So just imagine how amazing it is. There is so much to learn about the eye. Let us look at some aspects of the eye in this chapter. First of all, the field of view of our eye. What is the field of view? How much can we see using our eye? It doesn't mean that when we are looking front, do we only see what is front, or can we even see the sideways things also? Even though we are looking front, we can still see some part in the right and some part in the left. Okay, so the field of view is huge for the human eye. But there is only a part of the view where we can see in 3D. Binocular vision means 3D, that is where we can not only see the object, but we can also tell how far it is. Okay, but when we are looking front, we are able to see those objects in 3D which are in front of us, but whatever is on the right and left of us, we will be able to see them, but we will not be exactly able to tell how far it is. If you have seen the thing before, then that is different. You will be able to tell how far it is because you have seen it before. But if you go to a new place, then you will have to experiment and see that yes, you cannot tell how far it is. Okay, let us compare the field of vision with a camera. A CCTV camera, how much can it see? It can see only where the camera is pointed at. But human eye, it can not only see where it is pointed at, but it can see a little more wide angle also. So human eye is much better. So instead of here CCTV camera, if you place a human being, it is so much more nicer. Let me show you a little more about binocular vision. Okay, binocular vision is how we see 3D. How are we able to tell how far the things are? It seems so common, but it is also, we have to learn why it happens. Whenever both of our eyes see the same thing, then we feel that it is 3D. Then we will be able to tell the depth of the image. This is an experiment. I have shown this slide because if there are two images, both the images are same. Okay, now if you focus at here in the center or here, okay, if you focus your eyes here and if you relax your eye, so first focus your eye here, then relax your eye, then these two will become blurred and they will merge to form one more image here, and that will be in 3D. Okay, that is a good experiment actually, but I don't know whether you'll be able to do it easily because it will require some practice. Even if you are not able to do it, don't worry. I'll show you this how VR headset works. Have you seen VR headset? People wear this like this and the people are able to see things in 3D. Okay, how is that happening? That is because in VR headset what they do is the same image they show to both the eyes. Okay, when both of our eyes see the same image, we feel that it is actually 3D. Okay, isn't that amazing? because of this, actually we feel like we're actually looking at Eiffel Tower. And also there are so many other things like riding a roller coaster, playing several games, so many things that people have done using this VR headset. If you have, you can actually buy one. It is just a Google Cardboard, you might have heard. It is just 250 rupees. In Amazon you can buy it. Okay, I don't know whether it will be there in the village, but if you come to Bangalore, if your relatives are there here, I think you can order it and you'll get it. Just 250 rupees. You can buy it and you can look at it. Okay. Now let us look at human eye anatomy. What is the human eye made of? What is there inside? Okay. So if this is the eye, if we take out this eye like this, and then if we look at it from this side, then we will see it like this. First layer is the sclera, that is this one. First is this white color thing, that is called as sclera. That is an outer protective covering. Okay. Then comes the iris. The iris is the colored part of the eye. Okay. Before that we get cornea. Okay. You don't have to learn about that. I'm just telling the parts. Now pupil. Pupil is a hole. Okay. This black color part is the pupil. It is the hole through which the light passes through. Now then after that will come the lens. This is how the light will get refracted and it will form an image. To hold the lens in position, there are this suspensory ligament and ciliary muscles. These ciliary muscles, what they do is they will move the lens in such a way that we can see objects nearby and far, and also we can see the objects left and right to us. Okay. And this part is called as fovea centralis, or the color spot. This is where, so the image will be formed here. All this retina is there, but only in this particular area, the something called cones. There are two types of cells in the retina, rods and cones. Only cone cells are able to see color. Okay, so those cone cells are concentrated at this point, and we can see color only at this point. So the image, when it is focused here, only then we will be able to see it properly. In all the other part of the retina, we can see black and white, but we cannot see color. And then there is a place in the eyeball where the optic nerve goes to the brain. Okay, this part we cannot see anything, because even if the light comes here, there are no rods or cones cells here. Rods will see black and white, cones will see color. We don't have any cells here because the optic nerve is going. This is called the blind spot. Okay, because we cannot see anything here. Then here this part is hollow. What is it filled with? It is filled with something called a vitreous humor. It's a liquid. Okay, it is useful for focusing. Okay, the light will pass through this liquid and go and reach the fovea centralis. Before the lens also there is one more part, and this is aqueous body. There also there is some liquid called aqueous humor. Okay, now we have learnt about the anatomy. Let us look at it from the above, just to get a better picture. Here we saw the sclera. This is the word aqueous humor. This is vitreous body, and inside the fluid is vitreous humor, and the lens. Okay, and the fovea centralis, and what else? Yeah, the muscles. These are the muscles that hold them in place. See here, the muscles here. This is the iris. These are the muscles that hold the lens in place, and also when the muscles move, the lens also will move in such a way that we can see nearby things and far things, both. Let us look at dilation and constriction of pupil. So when you might have experienced this, you should have experienced this. When you wake up in the morning, when you open your eyes, what will you feel? You will feel like closing your eyes, no? Because the light is too much. You'll feel the light is harming your eyes. That is because when it is dark, okay, what will happen is, because it is dark, we cannot see much things. This pupil, the hole, will become bigger, so that more light can enter and fall on the lens. So if more light enters, then what will happen? The image is formed easily on the retina. So even in dark, because more light, whatever, it is not completely dark, no, little bit light will always be there usually. So that little bit light will also enter the retina and you can see things. So at night when you turn off the light, immediately after you turn off the light, you cannot see anything. But after 2-3 minutes, you can see properly, right? So this is because when you turn off the light, when the light is on, the pupil is this size, okay? Because we don't need to let so much light enter. If too much light enters, then it will harm the retina and destroy it. So that's why when it is like, when there is light, it will be this much. But as soon as you turn off the light, we cannot see anything because not much light is going. But after some time, the pupil becomes dilated and much light goes in and we can again see things better. See, this is an animation of, see, the pupil is small here. As soon as we turn off the light, it will happen slowly, not immediately. Now let us look at one more amazing thing, that is power of accommodation of eye. The ability of the eye lens to adjust its focal length is called its power of accommodation. What does it mean? First of all, focal length. So we know that focal length of a thin lens is more. Focal length of a thick lens, that is a fat lens, is less because it is more curved. So when the lens of the eye becomes more curved, it will make it in such a way that, see here, it is not very intuitive, but by looking at the image, I think you should understand. So when there is an image here, what is happening? The rays are coming from the image, they are being bent by this lens and they are forming an image here in the retina. Okay, this arrow we can see here. Similarly, when there is an image that is nearer, then it has to make it such a way that it has to intersect here only. Okay, so that the image is formed here. Here the focal length is little bigger, but here you can see the focal length has to become smaller. Okay, because so as soon as we are looking at a object near to us, then the focal length of the lens has to become small. So what will the muscles do? These muscles, they will make the lens fatter. Okay, then we can see the object. Then whenever we have to see a farther object, then the muscle will get relaxed. Okay, then the lens will become thinner. Okay, then we can see the image again perfectly because the focus is more now. If the focus was here only for the farther object, what would have happened? That farther object would have not been able to come focused, so we will see it little blur. That if you have used a camera, you will understand. When you have focused, so when you have focused the camera to zoom, and then if you see nearby object, it will appear blurred. But if you have set it to nearby object and if you try to see farther object, then it will seem blurred. So you have to change the focal length of the lens so that you can see nearby, focus on nearby and far objects. The camera we have to press a button and do, but in our eyes it happens automatically just by thinking about it. Just imagine, you just think about this, okay, I want to see nearby, then immediately the lens will become fatter, then you will see near. As soon as you feel like you have to see farther things, immediately the lens will become flatter and you will be able to see farther things. How amazing is that? So now there is one point called near point of the eye and one more is far point. What is near point? The minimum distance at which objects can be seen most distinctly without strain is called least distance. Okay, so what is it? When you are holding a book with you, okay, how close to your eyes can you keep it? When you are comfortably reading a book, you will keep it at a distance, no? At that particular distance, it is much easier for you. But if you bring it closer than that point, then it will become difficult for you to read. It will cause more strain. So for a young adult, the near point is 25 centimeter. So at 25 centimeter, if you keep the book, then it's okay. You will not feel that much strain. But if you keep the book very close to the lens, then it will become really difficult to read. Similarly, there is a far point. Now, don't get confused of seeing things clearly. Means it doesn't mean that even if the object is very small and if it's very far, then you obviously cannot see it clearly. But you need not strain your eyes. For example, if there was an object which was big enough, for example, a big balloon is going, that is a parachute or something is going in the sky, you can still see it clearly without straining your eye. So that is because the far point of the human eye is at infinity for us. So even if for the sun also, if during sunrise and sunset, if you want to see the sun, you can directly see it without any problem. Even though the sun is so far, you can see it without strain on your eyes, because the far point of the lens is infinity, but near point is 25 centimeters. So nearer to that, you will feel strain. But how much ever far the object is, as long as it is big enough, then you can still see it clearly. Now let us we have looked at amazing aspects of eyes, how amazing and beautiful they are, but there are some problems that may arise with the eyes also. Let us look at the problems. First one is myopia. What is myopia? It is the condition where person can see nearby objects, but he cannot see distant objects clearly. This is where all of us, the younger generation, if a person below 40 years of age has specs, it is most likely because he has this problem of myopia. Okay, what happens in myopia is, in normal eye what happens, the light rays go and they intersect at this color fovea centralis. But in myopic eye, because of some reasons, I'll tell you the reasons, what will happen is the rays will be focused here only instead of here. So that's why the image will be blurred. Okay, for farther objects. Okay, what will happen? When the person has myopia, then it means the far point of the eye will become closer to infinity, because if the person has specs, it means he cannot see the far things properly. So even if there was a balloon that is going in the sky which is big enough, normal people can see it, but person with myopia cannot see it clearly. Okay, so the far point would be closer than infinity, and the defect might arise due to excessive curvature of the lens. See, if the lens is too curved, then the rays are focused nearby. So that's why if the lens become too curved, instead of focusing far away, the rays are focused here. So that may be one reason. One more reason is the elongation of the eyeball. See, the normal eye is this much. Myopic eye, it might have elongated like this. Then what happens is, it will come till here. It's actually papa lens is working correctly, but because the eyeball is elongated, this point is wrong. It has to come even farther to focus. So that's why myopia will happen. Two reasons might be there. Now to correct it, what to do is, see, the light rays are coming like this. Okay, so if we make them diverge a little bit and then converge again, so then it will go farther. See here. Here the light rays are converging here only. But now what we did was, even the light rays are coming here, we have put a biconcave lens so that it diverges first and then it will converge. Then what will happen is, it will come and converge at the correct point. Then we can see the objects clearly. So this is what a specs actually does. Let us come to the next problem, that is hypermetropia or farsightedness. So a person with hypermetropia can see distant objects clearly but cannot see nearby objects clearly. For example, a person may be able to see any, like a board or something of a classroom, but he might not be able to see the book nearby or the newspaper properly when you are reading. This problem happens only for people above 40 years of age. Okay, so if people who are above 40, most probably they will have hypermetropia. This happens because
instead of focusing here, the light rays will become focused at farther from the retina. Okay, so farther from the retina means obviously the light will not go beyond the retina. It means if it was possible to go, the light would go here. So but it cannot go. So what will happen is without the light being focused, that only will, whatever light is there, that only will fall on the fovea centralis. So it will not be a good image, it will be a blurry image. Okay, so this happens because the focal length is too long. If the lens has become thinner, then the focal length has become more. Because the focal length has become more, it will try to focus at farther point. Okay, also it can happen if the eyeball has become too small. See, normal eye, here the eyeball has become too small, so it is not able to focus it correctly. It can be corrected by using convex lens. Previously we used concave lens, here we'll use convex lens because there we have to divert so that it can reach farther, but here it has to reach nearer, so we have to converge it. So already light is coming like this, we will converge it even more so that finally we will get the image at the correct spot. Okay, what else? Also, the last, in myopia what had happened, the far point for the person had become closer than infinity. In this thing, hypermetropia, the near point for the person has become farther away from 25 centimeter. So for us normal people, if you keep the book at 25 centimeter, you can read it, but for person with hypermetropia, you have to keep it even more farther to read it properly. The next one is presbyopia. In presbyopia, what happens is you cannot see things clearly, not because the eyeball has become bulged or it has become smaller. It is because the muscles, the ciliary muscles, I'll show you, wait. The ciliary muscles, these ones have become weaker. Okay, because the ciliary muscles have become weaker due to aging, then what happens is it cannot bend, it cannot bulge the lens, or it cannot make it thinner very easily as it does in younger age. So what happens for old age people, you might have seen them putting a reading glasses. That is because the power of accommodation of eye has become lesser. Okay, the near point would have become again farther, just like hypermetropia. Even in hypermetropia, the near point has become farther, but the reasons were different. The effect is the same, but the reasons are different. So for presbyopia also, person cannot see nearby things, but the reason is because of aging and because the ciliary muscles have become weak. Sometimes what happens, a person may suffer from both myopia and hypermetropia. Okay, such people will require bifocal lens. So if person is not able to see farther thing also properly, and you cannot see nearby things also properly, so to see farther things, he needs a biconcave lens, but to see nearer things, he needs biconvex lens. So what they do is, in the same specs, here they will put biconcave, here they will put biconvex. So for reading, if we look down, it is a biconvex lens. If you look up, it will be a biconcave lens. So this way, both the types of vision defects can be corrected. One more is cataract. Cataract is a formation of this calcium carbonate coating on the eye, because of which it becomes milky and cloudy. Okay, the see like this, you can see on the lens there will be a coating. So this condition is called cataract. This might cause a complete loss of vision or a partial loss. If the coating is on part of it, you can still see little bit through whatever is remaining, but if the coating is completely covered the lens, then you can't see anything. It is possible to cure this by using surgery, but the surgery is very costly. It is like for one eye, it is 25,000 or 50,000. Okay, so this is cataract. So this will complete the part of your human eye. In the next video, we will look at colorful world. Okay, see you, bye.